Today we're going to be looking at plotting the line of best fit, both on paper and using the TI-Nspire. So I've got an example from the CIM Extended Hayes and Harris book. And it says 10 students were surveyed to find the number of marks they received in a pre-test for a module of work and a test after it was completed. So these are the test results, pre-test, which is going to be the X values, and the post-test, which is going to be the Y values. So the X ones are usually going to be defined as the independent variables, whereas the Y ones are going to be the dependent ones. So the first thing to note when you're doing a scatter graph is when you're trying to get the line of best fit, you're going to need the mean value of the X values and the Y values. So part A is asking us to find that point. So find the mean point X bar, Y bar. Okay, so we usually use this bar notation to show us the sample. So this is probably going to be only 10 students of probably a lot of them, of maybe a whole class or a whole year group. So to find the means then, we just add them all up and divide by how many there is, and that's what it's doing in part A. So X bar is going to be 60 and Y bar is 71, and we're going to need that point. So then it says draw a scatter graph of the data, mark the points X bar, Y bar on the scatter diagram, and draw in the line of best fit. So that they've drawn it, they've not labelled the axes, which is not good. Oh yeah, they did X and Y. So they've used this squiggly notation here to show that there's values missing. And there they've plotted the mean and they've drawn the line of best fit through it. Okay, so there will be a margin of error when you do this in an exam, so don't worry too much about it if you don't get it exactly right, just as long as it goes through the mean point. Okay, so you're going to need this line of best fit in order to try and guess at values that students that may have got. So part C is saying estimate the mark for another student who was absent from the post-test but scored 70 for the pre-test. So their X score was 70, and you're going to try and use your line of best fit in order to find out what their post-test might have been. Okay, so 70 and then read across gives you 80 for the Y value. Okay, and that's called interpolation. When you're using the line within the range that you've got, then it's called interpolation. If you'd have extended this line further and further out, then it's called extrapolation. So maybe, for example, you want to know what if a student got 95 on the pre-test, what would you expect them to have got on the post-test? Okay, so that would have fallen outside the range. So that's extrapolation, which they're using a lot now with this COVID-19 models, trying to guess at what's actually happening. So how do you do this on the TI-Nspire? First thing, click the on button and delete all. And this is going to delete all the stuff that you've got stored in there. So new document, and we want a spreadsheet. So the TI-Nspire works downwards rather than crosswards, but that's okay. So X, which is the independent variable, is going to go down, and we'll start typing them in. So probably a good idea if you copy what I'm doing at the same time. 79, 60, 65, 30, 73, 56, 67, 45, and 85, and there's 10, which is correct. And then we need the Y in here. Make sure you just type in the top line. This one's going to be used for formulas, which we don't require at the moment. So 48, 91, 70, 71, 50, 85, 65, 75, 60, and 95. And there's the data in there. Okay, So we're going to see what it looks like on a graph. So we'll have to insert a new page. So we go to Control and then Doc. You can see it says just plus page above there in blue. And we're going to enter a data and stats page. So it's all over the place at the moment because we haven't told it what the axis is going to be. So on the x-axis, easy for us, x, and on the y-axis is going to be post values. And there we have nice correlation, nice positive correlation is going up. There's definitely some kind of relationship between the two of them. Okay, but how good is that relationship? We'll find out. So first thing, we're going to try and put this line of best fit onto the graph. So menu, analyze, regression, and we're going to do a linear regression, mx plus b. Okay, so this is a linear regression, and this is the formal way of finding a line of best fit for the set of data. Okay, so y is equal to 0.891 x plus 17.5, and the tests are probably going to ask you to find out what this linear regression line is and then just write it down. So you'll have to do it to 3 significant figures. So how good is this? How good is this line, and how well does it actually fit our data? Well, there's a value that we can find which is called the R value, which tells us how well this line fits the data in terms of the linear line. Okay, if I go back to my data, I can insert all of the information here just like we've done before when we're doing all the stats. If we go to menu and then statistics, stat calculations, and we're going to do linear regression, mx plus b. The x list is the first one we put in, which is x, and the y list is just the y, and it's going to enter all the information into the f column. And there we have it. So here's the linear regression. I can just use the arrows to scroll around. It's putting in the form of mx plus b, where m, the gradient, is 0.89, which is the same as what I had over here. And b value is 17.5, same as what I had. But the good thing about this is we've also got this r value, okay, which is significant because, like I said before, this is called Pearson's correlation coefficient. And these values are important because they tell us how close to linear a set of data is. Okay, so this is telling us the R value is 0.974792, which is really close to 1. And what happens is the R value goes between -1 and 1. So if it's 0, there is no correlation at all. Okay, but if it's more than 0.75, if it's between 0.75 and 1, then we class it as strong correlation. Okay, if it's between 0.5 and 0.75, then we would say it's moderate. And note they've used the absolute value symbol on here because these can actually be negative. Okay, at the moment we have positive correlation, so these values are going to be positive R, but it could have been coming downwards for negative correlation. Okay, in that case then these R values would be negative. Okay, so we found the linear regression line, which is there, and we've also found this R value to tell us how well, how good this data is in comparison to a straight line. Okay, hope that's been helpful.